Good morning everybody, and once again welcome back to the video. In this video you're gonna be learning about file sizing in Apache Hudi. So essentially mastering file sizing in Apache Hudi, boosting performance and efficiency. So everything that you need to know about file sizing would be essentially there in this video, followed by a small hands-on lab. So let's get started with the video. So why is file sizing so important, right? The reason the file sizing is important because a small file size can essentially deteriorate your query performance, right? When you are querying the data using Presto or Athena, whatever that is, if you have a lot of small files, it's gonna take more time to perform your queries. Versus if you have a large number of files, it's good for the query, but it's not that great for writing purposes, right? So let's understand how you can control the file sizing in Apache Hudi through these two configurations. So let's take a look at the diagram. Hopefully this should make sense, right? So if you set again by default, Hudi Parquet max file size, it's set to 120 and the small file size is set to 100 megabytes. So when you write something, let's say what would happen is, some data went to the blue file, some data went to the green file, some data went to the red file. So 20 megabytes here, 30 megabytes here, and the 120 megabytes in the last file. Again, 120. Why 120? Because that is what the max file size is, right? So when the next times a new writes or new insert or updates come in, first it will try to fill the blue file. Now the blue file still has about 100 megabyte space, right? Since you define this as 120, so the 100 megabyte worth of data will go to the blue file. Now the green file has about 90 megabytes data left, so that will go to the green file, and then again the rest will go to the newer file. So hopefully that makes sense. Now when you set the Hudi Parquet small file size limit to 0, what happens is this is what's gonna happen. So let's say you made some writes, so you have these three files, same scenario, blue, green, yellow. Now when the new inserts come in, it wouldn't basically try to fill the old files. It's simply gonna insert into the new file group. So again, I've written that here. New inserts are always routed to the newer file groups and only updates go to the existing one. So hopefully this diagram explains about these settings, right? And how you can control file sizing. Now let's just read a couple of sentences. Hopefully this should make sense and we can perform a small lab session. So Hudi Parquet small file size. The parameter sets the threshold for identifying small files. The default value is about 100 megabytes. Smaller file size can improve the write performance as they can be processed faster during the ingestion. Hudi Parquet max file size. This parameter determines the desired size for the Hudi managed file. The default value is 120 megabytes. Larger file size can be beneficial for query performances as reading from larger file is generally faster. However, larger files may increase the write latency during ingestion. So you have to choose a sweet spot between both of them. It is generally recommended to have a target file size between 100 to 500 megabytes for a faster Parquet reading. However, the optimal size depends upon the cluster configuration. If your cluster is suited for efficient resources, larger file size can be used, but it is advisable to stick around 200 to 200 megabytes for most of the scenarios. Now, I do want to mention, again, when you're working with extreme high velocity data, right, you want to write the data as fast as possible. So during those scenarios, having smaller files makes more sense. And then performing clustering and essentially grouping smaller files into a larger files. That could be done in an async mode. Again, depends upon the workload. If you're working with streaming data, probably small files make more sense, and then you can cluster smaller files into a bigger, larger files. But if you're doing more batch-oriented approach, probably you want to set the max Parquet file size to about 200 to 300 megabytes, right? Depending upon your use case. So hopefully that made sense. Again, just reading this and then we'll do a lab. Clustering can also be employed to improve efficiency for larger files in an async mode. By clustering related data together, the query performance can be further optimized as it reduces the amount of data needs to be read for a specific query. To ensure newer insert always is routed to the newer file groups, and updates goes to the existing one, set hoodie parquet small file size to 0. When you do that again, it will create new files again, and it would not fill the older files again, as shown in the diagram here. Now let's see a small lab. Over here I define my PySpark. Then over here I'm declaring a Spark session, as you can see. And again, this code notebook is available on my blog, okay? After defining the Spark session, I create a class to generate some fake data. Again, this generates some fake random data, right? So that we can play with. So this is the first test. So my table name is hoodie large files tst_1. And over here, if you observe, I have set the hoodie parquet max file size to 512 megabytes. And the small file limit is basically up to 100 megabytes. And then again, for simple loop, I'm essentially performing an upsert on the hoodie data lake. And the same thing I'm doing for tst2 table. And this time I set the small file size limit to 0, and then I perform the upsert again. Now go to your computer, and you can actually see in the first case you will see a larger files in your computer, parquet files. In the second case, the file size will be smaller, as new inserts are directly going to a newer file group, and updates will be touching the older file group, as explained. So thank you so much for watching the video. I hope this clears the concept about file sizing in Apache Hoodie. If you have any further question, please let me know in the comment section below. And a special thanks to Mr. Siva Balanarayan, where I was able to learn all these concepts in a much easier way. So thank you, Mr. Siva, for publishing this article. And as usual, if you have any other questions, please let me know. If I don't know, I'm gonna learn and let you know about that. With that being said, keep smiling, keep programming, and I'll see you in the next video.